Hi all. In this video, I am going to explain the speed control of DC motor. Generally, a DC motor can be a shunt motor or a series motor. Let us consider a shunt motor. With that assumption, we'll carry on with the further slides. Now, generally, whatever may be the type of motor, we opt two different methods of speed control. One is armature voltage control, the other one is the field current control method. And in armature control method, we have a motor here and a shunt field winding here. Assuming this is my armature and this is my field winding. If I say it is armature voltage control method, I will be varying the armature voltage, maintaining the field current constant. And if in case I opt the field control method, then I'll be varying the field current flowing through the field winding and maintaining a constant voltage across the armature voltage. This is the torque speed characteristics of a DC motor. X-axis is speed and y-axis is torque. And there is one more term available in this characteristics, which is constant torque and constant power. The understanding should be made that when you opt or when we consider the armature voltage control method, there will be a constant torque whereas variable power. If in case we go on with the field control method, there will be a constant power with variable torque. The graph actually goes by this way. This is the variable torque for the field control method and the power will be constant. Whereas in armature voltage control method, torque will be constant whereas power will be varying. This is the understanding. Okay. Now we'll move on with the armature voltage control method. As I mentioned earlier, I have a DC motor, shunt field winding because it's a DC shunt motor. For armature voltage control method, we'll have the motor connected to a fully controlled full wave bridge rectifier, and the shunt field will be connected to another bridge rectifier which is full of diodes. I'll explain why. Now here the available supply is AC, so that is converted or rectified by means of a rectifier, fully controlled rectifier, which has 4 thyristors T1 to T4, and the final DC supply is given to the motor, assuming this as a RLE load. Now, during the positive half cycle, T1 and T2 will conduct. During the negative half cycle, T3, T4 will conduct. Irrespective of the pair of thyristors conduction, the armature will be having only positive potential, as this node will be positive and this node will be negative. Since the armature voltage is varying and the shunt field is constant, this bridge rectifier is only having diodes instead of thyristors. Here D1 and D2 will conduct when it is positive half cycle, and D3 and D4 will conduct for the other half cycle, and therefore this is how we control the speed. This firing angle is varied, thereby armature voltage is varied, and hence the speed is controlled. This is an open loop speed control system. Now this circuit helps us to understand how a closed loop control of DC shunt motor will be. And I've explained how an open loop will be. So we have this thyristor bridge. It was a single phase thyristor bridge. I have explained in the previous circuit. Now I am showing this block diagram representation, which is a closed loop system. We have the DC supply, which is acting as a reference voltage, which is fed to the ramp unit. This is our comparator, which compares the reference voltage and the feedback. Here, this is nothing but a limiter, speed limiter. Ramp unit is nothing but a speed limiter. We have this limiter to limit the range threshold, and so that acts as the reference value that is compared with the original value, feedback speed, and fed to the error amplifier. Then it is given as the firing angle. Phase shifting circuit is nothing but the triggering circuit, which is connected to the gates of the thyristor bridge circuit. And this thyristor, after converting this AC supply to a DC supply, is fed to the motor here. What we have seen earlier was the AC supply connected to the rectifier, which converts or rectifies into DC, and that is fed to the motor armature. Whereas we have not seen how the thyristor gates are being provided a voltage, and that is what is shown here. The gate potentials are obtained by this feedback part if it is a closed loop system. And with the help of tacho generator, we sense the speed, and that is fed back to the comparator. And this is the field winding where we have a constant DC supply, as this is an armature control method. Thank you.